Hello everyone, myself Apurva, and today the topic of my video assignment will be algorithms. Algorithms are a set of instructions that a computer follows to solve a problem or complete a task which is given to it by the user. They are like recipes for the computers telling them exactly what steps to follow to get the desired outcome. Algorithms may seem complex, and they are actually used all around us in our daily lives, from the way we search for information on the internet to the algorithms used by the social media platforms to show us content. Algorithms play a crucial role in the modern society. The basic components of an algorithm. The basic components of an algorithm typically consists of a series of well-defined steps that are executed in a specific order to solve a problem or perform a task. Now, there are six basic and important steps which are followed in an algorithm. The first one is the input. Algorithms take input as data or information on which they have to work or operate. These inputs are the problem's initial state or the data required for the task. Second step is initialization. The algorithm sets up any necessary initial conditions, variables, or data structures that will be used throughout the process. It prepares everything needed to start the execution. Third one is steps or instructions. This is the heart of the algorithm where a sequence of steps or instructions is defined. Each step performs a specific operation or computation using the given input or data. The steps are arranged in a logical order and they are designed to lead to the desired outcome. Flow control is the fourth step, where the algorithm uses four flow control structures like loops, like while loop and for loop, or conditional statements like if-else statements to determine the order in which the steps are executed. Flow control allows the algorithm to make decisions and repeat steps as needed. Termination. Termination, the algorithm has a defined endpoint or termination condition, which indicates when the task is complete or when the algorithm should stop executing. The sixth step is the output. After completing all the steps, the algorithm produces the desired output or result. This output could be final answer, a solution to the problem, or any processed data. Working. Algorithms consist of a sequence of steps that must be followed in order to reach the desired outcome. The first step in executing an algorithm is to identify the problem that needs to be solved. Once the problem has been identified, the next step is to develop a plan for solving it. This plan is known as the algorithm. The algorithm must be broken down into smaller steps, each of which can be executed by a computer. These steps are then translated into a programming language such as Java, Python, and C, and are then compiled into machine code that can be executed by the computer. The execution of the algorithm involves following these steps in order until the desired outcome is achieved. Here we have a simple example of an algorithm. So this algorithm we are going to use to find the sum of two numbers, where we are going to print the sum of two numbers. So here we are going to take the input from the user as the two numbers, which is A and B, of which we are going to print the sum. And the step one in this algorithm will be reading the value of A from the user, and step 2 will be reading the value of B from the user. And the step 3 in this algorithm will be calculating the sum of A and B, which is sum is equals to A plus B. Then the step 4 will be displaying the result using the print statement. And in the print statement, we are going to be using the sum of A and B is sum. And here we are going to be printing the sum which we have found out here. And the step 5 will be end. So now in this example, the algorithm takes two numbers A and B as an input, calculates their sum and displays the result, which will be the sum of both the numbers. The algorithm follows a linear sequence of steps from input to output. The algorithms can be much more complex and may involve nested loops, recursions, and more advanced flow control structures depending on the complexity of the program they are trying to solve. Types. There are several types of algorithms, including sorting, searching, and optimization algorithms. Sorting algorithms are used to arrange data in a specific order, such as alphabetical or numerical order. Example of some sorting algorithms are in bubble sort, insertion sort, and quick sort. And searching algorithms are which are different from the sorting algorithms are used to find a specific item within a collection of the data. And the most commonly used searching algorithms are binary search and linear search algorithm. Lastly, optimization algorithms are used to find the best possible solution to a problem by optimizing a particular parameter. Example of optimization algorithms include gradient descent and stimulated annealing. Properties of algorithm. There are many properties, and the most important properties of the algorithm are well defined. Algorithms must have precisely defined steps, meaning there should not be ambiguity in which steps entails. The instructions should be clear and understandable by the user. Finiteness. Algorithms should eventually terminate after a finite number of steps. They should not run indefinitely or result in an infinite loop. Definiteness. Each step of the algorithm must be precisely and unambiguously specified. It should not have multiple interpretations for a single step. Correctness. An algorithm is considered to be correct if it produces the correct output for all possible valid inputs. It should solve the problem it was designed for accurately. Even if there are multiple inputs given, the output of the algorithm should be correct and the desired output. The efficiency. Algorithms should be designed to perform the task efficiently, utilizing resources like time and memory effectively. The efficiency of algorithms is often analyzed in terms of time, complexity, and space complexity. Adaptability. Some algorithms can adapt to different input or problem sizes, remaining efficient and effective in various scenarios. Scalability. The algorithm's performance should not significantly deteriorate when applied to larger instances of the problem. And time efficiency. Time efficiency, also known as time complexity, is a measure of how long an algorithm takes to solve a problem as a function of the input size. It quantifies the amount of time required by an algorithm to execute in relation to the size of the input. It's important to design algorithms with efficient time complexity to ensure they can handle large input sizes and execute within reasonable time frames. However, time complexity is not the only consideration when evaluating algorithms. Factors like memory usage, ease of implementation, and problem-specific requirements also play a role in selecting the most suitable algorithm for a particular task. Space efficiency. Space efficiency, also known as space complexity, is a measure of how much memory or storage can an algorithm require to solve a problem as a function of the input size. It quantifies the amount of memory used by an algorithm to execute in relation to the size of the input. When designing algorithm, it's essential to consider both time complexity and space complexity as a trade-off often exists between them. Some algorithms might have a low time complexity but require a significantly higher amount of space, um, while others may be more memory efficient, that is, they may consume less amount of memory but take a longer time to execute, which increases the time complexity. The choice of the most appropriate algorithm depends on the specific requirements of the problem and the available computational resources. Asymptotic notations. These are the notations used to uh, describe the time complexity and the space complexity of the algorithms. There are three main asymptotic notations used. One is big O notation, big omega notation, and theta notation. Now, big O notation. Big O notation is a mathematical notation used to describe the upper bound of an algorithm's time complexity. It represents the worst case scenario for an algorithm's running time as the input size approaches infinity. And big omega notation. Omega notation is used to describe the lower bound of an algorithm's time complexity. It represents the best case scenario for an algorithm's running time. Theta notation. Theta notation is used to describe the tight bound of an algorithm's time complexity. It represents a range of functions that can have both an upper and lower bound, meaning that the function grows at the same rate as the best and worst case scenarios. Applications. Here are some of the applications of algorithms. Algorithms are used in search engines, which are used to find, index, rank, and retrieve relevant information from vast amount of data, enabling search engines to provide relevant search results to the users. Sorting. Sorting algorithms arrange data in specific order and they are used in databases, file systems, and various applications where data needs to be organized for efficient retrieval of the data. Machine learning. A wide range of machine learning algorithms are used for tasks such as pattern recognition, classification, regression, clustering, and recommendation systems. Natural language processing. Algorithms are used to process and analyze human languages for tasks such as text summarization, sentiment analysis, and language translation. Data mining. Algorithms are used to discover patterns, correlations, and trends in large data sets for business intelligence and decision making. Robotics. Algorithms are used for robot control, path planning, and navigation in autonomous robots. Game development. Algorithms play a crucial role in game development, including pathfinding, collision detection, artificial intelligence for game characters, and procedural content generation. Conclusion. Algorithms form the backbone of modern computing, enabling the development of software, applications, and systems that power our daily lives. They are used in wide range of fields such as artificial intelligence, data analysis, cryptography, optimization, and more. Algorithmic thinking is essential for computer scientists, programmers, and problem solvers to devise effective and efficient solutions to real-world challenges. In conclusion, algorithms are fundamental tools used in computer science and problem solving that provide step-by-step instructions to solve specific tasks or problems. They are like well-defined recipes that guide computers or humans through a series of actions, ultimately leading to a desired outcome or the solution. Thank you.